Okay, so let's do more testing on this motherboard. So this time I'm using a benchtop power supply. One thing I did notice very interesting is the power usage is kind of odd. So CPU definitely does not come up, or maybe it does, but I don't pick up a multimeter. So we're going to go ahead and do some advanced detection using the oscilloscope here. We may even use thermal camera. Let's see. So we've got a benchtop power supply set up now. So here I should have the benchtop power supply displayed. Okay, there we go, and there we go. So unfortunately, what is it? Benchtop power supply. This one. Filter. It's crop. Top. Just fix that up a little more. Okay. Okay, so that's that. So if I plug in the power, 19 volts, it's going to give me a nasty shock maybe. So plug in the power. Power is currently on. That was me doing the RAM. Okay, here we go. So pressing the power button. It never goes above 15, which is so strange. It's like the BIOS is not booting. CPU isn't starting, you know. This is really strange. Alright, so that's the power we do know now. Let me just check something here. I've got a power sequence for this motherboard. A proper power sequence. Found it in the pages. So, okay. Okay, so let me go back to here. Okay. Which page was I on? I was on a page which had here we are. So I did a check. So it's all okay up to here. That's okay. Here, 1 volt CPU core will not come up. I don't know if you can see what I'm saying. Yeah, you can. And if you look at the schematics, it actually comes from here to here. So this chip here, through here, here. This is 1 volt CPU core. Okay, so it's everywhere on the board, we can see. So what we're going to do, bring in the oscilloscope to detect, see if VCORE actually comes up before it shuts down. Okay, so let's cut the power for this baby. Let me see what you're saying on the screen. Let me see if I can do this way. 1 second. No, okay. What we'll do, we'll leave it there. Going here. Okay. Benchtop power supply and multimeter we don't need. Probes we may need. Let's push to the side. Power supply is here. Push it down. Okay. Okay. I need to add one more camera to the system. It's already crazy. Okay, so here, so when system is on, just say powered on. It's on, right? There is a what you don't want to start now. Oh, it's on. Sorry. Here we go. It's on. Okay. So this capacitor is here. We see so 5 volt divider. Let's go to 1 volt divider. So 1 volt divider, we don't see anything. Yeah. Okay. What? Did anything change when I removed? Okay. No. So what we're gonna do is we're gonna see if it does come up. A little bit at least. Okay, 800 nanoseconds. Okay, so power is currently off. Power on. Nothing. So what I'm gonna do, I'm gonna go single sequence. Power button. Nothing. 0.5. So that's 500 millivolts. We're on 1 time. It's really strange. Okay, now power on. Yep, blue light. He's not even coming on. So that's so interesting. Try the other guys. No. So this voltage comes from this chip here, which is, so what we'll do now, we'll switch to here. Okay. So you won't see oscilloscope, no biggie. At least we got a multimeter. Here, this chip here, which is PU4601 and PU4601. So by the way, that connection that I just measured, CPU VCORE, comes to here, that guy there. So even if we check there, let's say if it was a trace issue, that would be a good idea, good thing to know. So I'll cut the power using the oscilloscope, and nothing. I'll just see if there's anything else around the board, see if the oscilloscope is actually working or not. It's actually working, yeah. Okay. So we get actually nothing there. Okay. So now let's have a look. So this guy, 1 volt CPU core, as per schematics, VR enable. Let's say here, let's say this guy, VCC ST power good, VCC VCCS T underscore power good. Okay, is it here? No, why will it be easy? It's gonna be on the other side. Yeah, okay. Let's disconnect. Cut the power. Rotate the board. And it's telling us it's gonna be there. Okay, I can see it. Okay, so there's a dot there we can measure. So plug in the power. Get a ground for the oscilloscope. Okay, let me see. So if let me see what you see. Okay, so we're gonna check this guy here. Nothing at the moment. Plug in that, press the power button. It does come on. Peak 940 millivolts. So yeah, and then yeah, there we go. It's actually working. So here we can see it working. Yeah. So I'm gonna cut the power. Power is off, and I do single. Press the power button. Okay. Maybe time is. Okay, let's do it again. Let's cut the power. Okay, and run single. We can bring the trigger a little bit more down. There we go. Single. It's a bit too close, but there we go. 1.02 volts. Okay. So he does come on. So VR enable. Where is VR enable? Who's doing the VR enable? Power VR enable. So that should be from that chip on the other side. Yeah. Okay. Let's go back. Repeat the process. So this guy is not enabling the power. So it's either that chip is faulty or something's not right with that chip. Okay. I think this is where it's gonna get ugly. So let's see. So by the looks of the diagram here, it should be that guy there, which is pin number. So this is pin number 37, power VR enable. Okay, pin number 37. Oh, you can't see. Okay, here we go. Yeah, right there. Okay, so I'm gonna press the power button. So peak is 2.34. Yeah, it's telling it to be enabled. If we reduce the voltage from 500 milli, yeah, it's a minimum, it's a maximum 3.1 to 3.16. So he is, by the looks of it, okay. See? So it's saying enable, but the voltage is not coming. Why is the voltage not coming? So here is where it should be. Fuck. There. But it's not coming. Now this guy, is it connected there somehow? Yeah, the board is a bit, fans are on. Now let's bring the multimeter. So there's no power in the system. Okay. See if they're connected. They are connected. Okay, no problem there. So that's connected here to there, no problem. And that connects to here. Okay, and there to ground, we get 8 ohms. Okay. Now I've got, this is a 2AE. I've got 2AJ. I haven't got 2AE. What do I do? Now, is this chip faulty? I don't even know. How will I know? Okay. One way to know will be, let's have a look at schematics of that chip. So let's go here, AE. Let's bring it schematics. Come on. What the hell is wrong with you guys? Open with. Seriously, okay. Okay. So the pin we're interested in is 47. Maybe that's not where it's coming from. Well, it all means mumbo jumbo to me. Far out. So you can't sense whether it's working or not. But enable we have 3.12 volts. Alert, alert, alert. 33. See if there's a... So if it's asserted, then there's a problem. But if it's not, then it should be fine. So 33. So... maybe I'm not reading the chip properly. Let me check. No, I am, yeah. And 33 is there. Which is fourth one from the back. Yep, here we are. Hi. Yeah, I'm not reading anything. So, pin number 33. VCORE alert. If it's 0, then that's okay. If it was a voltage, then it will be a problem. Wait, fourth one, am I looking at the right pin? Yeah. Okay. So there's no alert there. The enable is there. 17 and 16 are reversed on the one I've got and the one they've got here. What a wanker. It's okay. PWM main. Let me check if any of these guys are going to ground. So what we'll do, we'll have a look in oscilloscope. Okay, just check my grounding is good. Yep, okay. So let's just go, I'll do it in beeping mode, it will be quicker. Okay, here we are. Just check my ground. Okay. Okay, 1, 2, 3, 4, 5, 6, 7. 7 is going to ground, let's see. Okay, that could be low resistance, okay. Now we should do it in ohms because this area is all CPU related. Yep. 8. That's fine. 9. 10. 11. 12. Okay. 13. Yep. 14 are going to be same. 15. 13, 14, 15, 16, yeah, 17. Okay. 18. 19. 19 is going to be not connected. 22. So 22 is the third one. 23. 24. 25. Okay, 25 may be ground. No. Okay, where is that going? Power VCCGT return. What the? That doesn't sound right. Where does it go on the other side? Here. Which goes to some resistor. VCCGT. VSSGT. VCCGT return. Oh. Wait. So these guys. So then that should be shorted to ground then. Let me see. Let me go back. looking at here, it's PU, that's the first one, going across somewhere here. There's no stuff here. Okay, I think we're looking at here. Okay, then that should be a capacitor there, which is ground. Okay. Okay, so that guy there should not be shorted. If it is, then we found our problem. Nah, it is not. That cap is fine. So this guy going to ground. No, it's not. Okay. Okay, let me double check. That's GT sense, which is there. Here to ground. So that's saying it is going to ground, which connects to here, which connects to there. There to there, and then where? Maybe here, and then where? And then to here somewhere. There, that's another resistor. Ground. Okay, R815, 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 R815. It's a 100 VCC GT, VCC GT, VSS GT sent. Let me check this guy. R814, R814. Oh, it's right on top. Okay. Okay. R814, so that's the one on top. Sheesh, where am I looking? Okay, it needs to be on the top of the... Yeah, there we are. Okay. Okay, so this guy in resistance, it's a 0 ohms. Why is it 0 ohms? How about the ground? 14 ohms here. Should be also 14 ohms. Yeah, correct. That's VCC GT. This is VCC in the VSS GT. So here to ground, reading short. That's ground definitely. But what's this value of this resistor? It's a 0 ohms resistor, R815. What the hell is VSS GT sense? What's the resistor value of the one on top? It's a 1 ohm? What's that? What does this mean? It's 100 ohms. It is 100 ohms. So this guy, I'm not reading 100 ohms, R815. Okay. R815, I'm not reading 100 ohms, that guy. That's because it's in circuit. So if I am reading dead short there, so it's one of two things, either VCC, VSS, something there is short at the ground, or this guy is not good. Let's check. Let's remove him. Okay, so it's gonna measure 100 ohms here for sure. I think I read 100 there briefly. Yeah, 100 ohms. Okay. Okay, it's safely there in the flux. So here to ground. So we're reading from here, which is ground, which is normal. And here we should not have a ground. Yeah. So that's 003. It's like 1 ohms. I don't get it. Okay, so what is this? VSS GT sense. What is that? Alright, I don't know what that is, but I'm going to put that back in and I'll measure the voltage on that. Okay. Great. There's 1 ohms there. Maybe that's just for sensing. Okay, let's check the voltage there using the oscilloscope. CPU won't be happy. It's about its temperature for now. Let's let it cool down. Here. There is no reading. Well, that's going to be ground. Yeah, nothing. No reading. Zilch. Nada. Okay, so we were looking originally at... Let's go back to... We don't lose focus. Go back to that other chip. So we're checking resistance, right? I think we're looking at here, yeah, 27 cents. VCC GT VCen. Okay, let me see what you're looking at. Yeah, okay. Alright, we got no power in the system. We're still in resistance mode, so let's continue. Let's check 27 again. So we continue. 27 being the third one. Here. 8 ohms. 28. 29. Is that the fifth one? Yeah. 358. 30. 30. 31. 32. 33. 34, 35, 36, 37, 38, 39, 40, 41, 42, nothing still. 43, 44. So 44 says some ground. What does it say there? VCC Acer return. Power VCC Acer return. Let me check. So that's the fifth one from top, right? 1, 2, 3, 4, 5. Okay, VCC SA return. VCC SA RTN. VCC SA. No, VCC SA RTN. And 1 ohms. Their cable resistance about 2 ohms. Okay, just something of interest. And then 45. Let's start from the top, which is 48. which is also going to ground. VCORE RTN. VCORE RTN. I wonder if RTN are all supposed to be 1 ohms. And 47, that's VCORE sense. 47 here. And so 46, 30, 45, 10 kilo, 44 was, yeah. And now let's go to VCORE VSS 20. Where is it that we had a low resistance reading? Somewhere here. Let's check. PWM 22. 22 will be here. 23. 24. 25. Yes, 25 it is, which is a VCC GT RTN, okay. VCC GT RTN 1 ohm. So if you have a look at the schematics now of this chip, for example, I didn't write the chip name, the pin number, okay, that's 25. And VCC SA return was 44. And the VCORE return. Okay, 44 or 48 and 25. Our ground main, okay. That's, and how about 44 and 25? Yeah, okay, and 44. Yeah, 44 will be ground. So this chip is actually working fine. Oh yeah. So what is the problem then? No point replacing that chip. Let's go back to that power sequence. Wow, okay. Let's have a look at DDR reset. DDR reset. Let's go maybe more. I think our answer is here somewhere. Okay, if you don't get that 1 volt CPU core, just want to see if PCH power okay is there. I know it's ridiculous, but I just want to see. Okay. Okay, it's all on the other side. Do you think this is a worthwhile time spending for making a buck? Answer is no, but the experience I get from this is fucking amazing. Okay. Okay. Is our PCH power okay? Okay. Let's see. Power is in. Okay, I don't know if my power adapter is, the oscilloscope ground is good or not. Check VCC. Pin number 1 of the BIOS chip, that's fine. Okay, so here. 3.32 is available. Okay, so that's PCH power, okay. Let's check here, which is the top one, which is there. Yep, 3.3. You know what, screw that CPU part, let's keep on going. I know, doesn't make sense, but if it's clear up to here, let's continue. So we're gonna look at, okay. So I don't get 1 volt CPU core, that's driving me crazy. How about VCC? That won't be there, I don't think that was there. VCC what? I think it will be the voltage, like 1 volt. How about VCC GT? 1 volt VCC GT, yeah. So that's the coil or capacitor there, which is here. Let's see if it even jumps. Power on. No, not even a jump. Okay. This somehow relates to CPU, PCH, something, not PCH, CPU. So 1 volt VCC is not there. PLT it should be 0. Which we checked before. Yeah, it is 0. Hi. Is this power okay? You never know, maybe it's just a super IO being a dick. So that will be 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10, which is there. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. System power okay. I get 0. System power is not okay. Or the EC is not talking. What if there's a problem with our EC? Hmm? 9028Q, KB 9028Q. Let's back out a little, have a break. KB 98Q. KB 9028. And that was pin number 106. which was U2401. Okay. And pin number 106. Yeah. Okay, the only thing I have left for this motherboard is to simply flash the Super IO. Oh, okay. Am I going to be able to do it? Well, 13-AG screen, not cheap, lady. Alright, I'll be right back. While I was preparing the quote, I don't think it's right to program the BIOS chip. Oh, sorry, the Super IO. Ah, one sec. Yes, mate? Yes, sorry. As I was saying, all system power good is obviously not going to be there if the VCC and the VCC GT are not there. So why should I replace or program Super IO? Doesn't make sense to do any work on that, right? If you think about it. So if you look at here, system power okay. Ah, wait. If we don't get that, but we did we get 1 volt VCC SA? Did I check these? Let me go again. 1 volt VCC SA. Okay. Okay. I'm gonna go back one by one. Okay. Let's do it again. All right. Here we go. So that is this coil here. Let's see. So we got 2, 3, 4th coil. Okay. Okay. Let's just go one at a time. All right. Yeah, he's there. One sec. Hello, is SureCan speaking?
Davey K. Good, thank you.
Oh yeah. Same one, but just bigger storage. Yeah, same size, yeah. Ah, 15.6 inch. Okay, that will be better, yeah? Okay, let me see if I can sort something out for you then. Easy. Alright, I'll talk to you soon. Bye-bye. Okay. Hello, okay. What was I doing? Yeah, that was there. Check that. Let me check that again. It's on at the moment. Yeah, showing 1.12 volts. Okay, so that guy is fine. Maybe, yeah, that's fine. Okay, let's continue. Go back here. Let's check this guy. 1D5VSO. Okay, here, HDMI. So 2 MOSFETs on top of that. There, I can see him. Here. Yeah, 1.6 volts. He's there. Okay. 3D3V Okay, so that's that one right there. Yep, he's there. Okay, 5 volt S0 is definitely there because we got the USB light on. Let's check it anyway. Here. I believe that's it there. That's weird. I mean, okay, wait. Oh, it's a fuse. Fuse, okay. What happened to the board? It's turned off? Okay. 5 volts, yes. Okay. So both sides should be 5, right? Yep, okay. Now which power supply am I using? Just want to make sure I'm using... No, the wrong one. I should be using the one coming off our power supply here. Where's that one going? Okay. Okay. Alright, now let's continue. Where's my mouse? Okay. 1 volt VCC IO. 1 volt VCC IO. Okay. He's not showing up there. Oh, VCC IO. Okay, there we go. Okay, that should be easy one, which is at the bottom, right there, which is that guy there. Yep, 1.12. VCC STG. Okay. Here. Interesting. So we don't have this guy, huh? Let me double check properly. No, he's there. Okay, 1.12. Okay, that's fine. PMSLP S3. PMSLP S3 hash. So that's active low. be there, which is, I can check there better. I can even check on the bottom. Okay, let's just check over. Oh, it's under the heatsink. Okay, I can check it on these resistors, so which is the third one. No, this guy here. Okay, it's a bit tricky, that one. I'll touch other bits. Let me try this guy here. So two MOSFETs, that guy, and then there's two things and that pad there. Oh, we got voltage there. That is not good. PM SLP S3. Oh, because it's currently on, right? I switch it off. PM SLP S3. It is not active. That okay. That's okay. So it's not sleeping. Okay, that's fine. V0D6V voltage reference. It's 0. Okay. Wow. It's everything there. Okay. Yeah, that's correct. 600 millivolts. Power VTT enable. Okay, so this one is next to that chip. Shit, excuse me. And it's 1, 2, 3 over there. .72. What is that supposed to be? SLP3. PM is power VTT enable. Okay, I think that's okay. Maybe partially enable. Okay. 1D2 V3 S3. Okay, it's these long ones. Well, I haven't got anything there. That means this guy. Yeah, 1.28. So he's there. That's the RAM. Ah, okay, so it does the RAM beforehand. Okay. Two D5 volt S3. Over there. Yeah, 2.6, that's correct. Yeah, 1.12. That's also there, okay. PM power button. So we get all of that, and then this all happens. This is power okay, still freaking 0. Am I checking the right place? 2, 4, 6, 8, 9, 10. Yeah. Okay. What's the resistance of 106? Going mental. I think the last resort I'm just gonna program the Super IO for no reason. So I don't know why. Okay. 2, 4, 6, 8, 9, 10. Okay, here we go. 2, 4, 6, 8, 9, 10. 1.1 mega ohms. Okay. Let's just program Super IO. Okay. I think I watched a million videos on that one and I had no success. RT809F 90 9028. I think it was 9028. 9028. Yeah. Alright, let's spend the rest of the day learning to trying to program. Alright, I'll get the environment ready. I'll come back.